Thabit was a prolific scientist of the 9th century. He belonged to the Sabian community, mentioned in the Quran. The Sabians descended from the Babylonian star worshippers because their beliefs were related to the stars. They produced many astronomers and mathematicians. During the Hellenistic era, they spoke Greek and took Greek names. And after the Islamic conquest, they spoke Arabic and began to assume Arabic names. Thabit, whose native language was Syria, also knew Greek and Arabic. Most of his scientific works were written in Arabic, but some were in Syria. He translated many Greek words into Arabic. When he was a distinguished scientist and physician in Baghdad, mainly under the reign of the Abbasid Caliph Al-Mu'tadid, 892 until 902, Thabit was a leader of the Sabian community in Iraq. His son Sinan and his grandsons Ibrahim and Thabit were well-known scholars in mathematics, medicine, and astronomy. Sinan ibn Thabit converted to Islam, thus putting an end to the Sabian tradition of the prestigious family his father had founded in capital of the Muslim Empire, and strengthened its integration in the Muslim society. In his youth, Thabit worked in Haran as a money changer. Mohamad, one of 3 Bani Musa brothers who was traveling through Haran, was impressed by his intellectual skills and invited him to Baghdad, where he became a great scientist.
In mathematics, Thabit Ibnu Qurra translated or edited in full or in part many Greek mathematical works of Euclid, Archimedes, Apollonius, Theodosius, and Menelaus. He also wrote commentaries on Euclid's Elements and Ptolemy's Almagest. His Kitab al-Mufrudat, consisting of 36 propositions in geometry and geometrical algebra, was very popular in the medieval times. مقالة في استخراج الأعداد المتحبة contains 10 propositions in number theory, including the problem first solved by Thabit of the construction of amicable numbers, which is pair of numbers of which the sum of the divisors of each is equal to the other. In Kitab fi Ta'lif an-Nisab, Thabit studied the theory of compound ratios. This theory later led to the notion of real numbers and to discovery of differential calculus. Thabit produced proof of the Pythagorean theorem and its generalization in Risala fi al-Hujja and al-Mansuba ila Suqrat fi al-Murabba wal-Qutri on the proof attributed to Socrates and the square and its diagonal. In Kitab fi Misahat al-Qata' al-Makhrut alladhi yusamma al-Mukhafi. Historians of mathematics consider that this computation, different from that done by Archimedes in quadrature of the parabola, is equivalent to that of the integral. The computation is based essentially on the application of upper and lower integral sums, and the proof is done by the method of exhaustion.
In astronomy, Thabit was the author of many treatises on the movement of the sun and moon, years, visibility of the new moon, and celestial spheres. In a well-known treatise extant only in Latin version, called De Motu Octave Sphere, he added an 8th sphere, that of the fixed stars, to Ptolemy's spheres, which is those of the sun, moon, and 5 planets, and proposed the theory of trepidation to explain the precession of the equinox. This theory first appeared in Islamic astronomy in connection with Thabit's name.